Are you able to see the screen? Right. Good morning, everyone. We will continue with the yesterday's class. Yesterday, we discussed about sinusoidal excitation with respect to RL series circuit. Okay. So today we will deal with RC series circuit. So RC series circuit, the resistance and capacitance is going to be connected in series across a voltage supply. V is equal to Vm sin omega t. Okay. So this is the voltage supply, what we are going to give, V is equal to Vm sin omega t, and the voltage drop across the resistance, we are going to take it as VR. Okay, and the voltage drop across capacitance, we will take it as VC, right? So, a uniform current of I passes through the entire circuit, okay, passes through the entire circuit. 1 minute, ma. One second. வேற ஏதோ தெரியுதா ஸ்கிரீன்ல? Right. Now, the voltage drop across resistance. Okay. See, I will just give a brief description about the RL series circuit, and then we will go into the RC, because I have got some request messages for RL series circuit. Okay. So in the RL series circuit, we know the resistance and the inductance are connected in series across the voltage supply. In the resistance, the voltage and current is going to be in phase with each other. And in an inductance circuit, the current lags behind the voltage. Okay. So we are combining this both together. We will be finding out the resultant voltage, right? This is the voltage triangle for the series RL circuit. Okay. So you will have VR as the voltage drop across the resistance, VL is the voltage drop across the inductance, and V is the voltage resultant voltage drop. Okay. So here we will be calculating first the impedance. Impedance, you know, Z is equal to R square plus XL square, where XL is going to be the inductive reactance. Okay. And it is termed, the formula for it is XL is equal to omega L or 2 pi Fl. Okay, where omega is the angular frequency and F is the frequency, right? Now, after calculation of the impedance, we will be calculating the phase angle. Okay, you know the phase angle. Phase angle is nothing but the angle between the voltage and the current. Now, in a pure inductance, the current lags the voltage by 90 degrees, right? But this is going to be a combination of resistance and inductance. So it will not be purely 90 degree, but it will have an angle, okay, with the resistance or with the voltage, right? So we will be calling this angle as phi. So if you see, this is the phasor diagram. In the phasor diagram, first the current is started, right? And then the voltage is starting. Starting point is going to be 0. So it will be a sinusoidal waveform. So we call the current lags the voltage by an angle phi in a RL series circuit. Okay. Now all in the combination of the circuit power, reactive power, and a apparent power. Okay, real power is represented by P is equal to VI cos phi, right? Where the current component is in phase with the voltage, right? And the unit for actual power is going to be watts. Clear? The second one is going to be the reactive power. We call the reactive power as also the quadrature power. We call it as quadrature power because it is going to have 90 degrees with respect to the current. Okay, and the unit for this is going to be volt ampere reactor. Anyway, I'll be telling all this for the RC circuit also. It will be a revision for you. Okay. Third one is going to be the complex power. Complex power is otherwise called as the apparent power. Here, apparent power, yes, it is represented, and the unit for this is going to be volt ampere. Okay, so this is going to be the resultant power from the real and reactive power. Clear? Next, we have solved some problems based on the RL series circuit formulas. Okay. Anyway, we'll be posting all this in your group. Clear? We will now move about the RC circuit. Okay. Now, in RC circuit, as I have already told you, the voltage drop across the resistance is VR, and the voltage drop across capacitance is VC. So, we will write VR is equal to, the formula for VR is going to be I into R. Okay, where I is the uniform current. Okay, so this is going to be I. Clear? So this is going to be uniform current I because this is a series circuit. In a series circuit, we have the current is going to be common, right? So the current flowing through the resistance and capacitance is going to be the same. VR is equal to IR. The voltage of the resistor is equal to I into R. Next, VC. Now, what is VC? VC is going to be the voltage drop across the capacitor. So this will be the value of I into XC. Okay. What is XC? I have told you all this in the last class. XC is going to be called as the capacitive reactance. Okay. Capacitive reactance is defined as 1 by omega C. Okay. What is 1 by omega C? It is not inductive capacitance, no, it is capacitive reactance. Okay, X is called the reactance. Okay, so if it is going to be XL, then it is called as the inductive reactance. If it is going to be XC, it is called as the capacitive reactance. Okay, the formula for XC is going to be XC can be written as 1 by omega C. Okay, 1 by omega C, where omega is called as the angular frequency, right? Now the unit for XC is going to be reactance, ohms. Okay. Now what is omega? We know omega is going to be 2 pi f. So we can write this as 1 by 2 pi fc. So XC can also be written as 1 by 2 pi fc. Okay, where f is going to be the normal frequency. Right? Frequency we have defined it already, right? So the same way we will be writing 2 pi f into c. Right. Now, coming to the phasor diagram. Now check with the phasor diagram here. We have drawn a phasor diagram here. VR is going to be the voltage drop. That is going to be in phase with the current, in phase with the voltage. Okay, voltage and current is going to be in phase because this is a resistor circuit. So we have drawn this on the x-axis. Okay, next, capacitance. Coming to the voltage drop across the capacitance, here the current leads the voltage in the capacitance circuit, right? So I have drawn this in the 90-degree quadrature, making it the voltage. Okay, now this will be the resultant voltage. Okay, now as this is the resultant voltage, now neglecting all the current and voltage, I will get a triangle like this. So this value will be R, okay, and this value will be XC, okay, and this is going to be the impedance, right? This is called as the impedance triangle for a RC series circuit. Okay, in an impedance triangle, you will be having only the resistance, reactance and the impedance. Voltage and current will not be present, right? This is called as the impedance triangle for RC series circuit. Okay. Now we will mark this angle as phi. Phi is going to be the angle between the resultant voltage and the current. See, consider this as the current, because the current, I told you already, it is in phase with the voltage. So the angle between the voltage, this is the voltage, the resultant voltage, and the current is going to be phi. Phi is called as the phase angle. Okay. Now for this circuit, we are going to find out the impedance. Now we know, as this series circuit, V, the resultant V is equal to square root of VR square plus VC square. Okay, VR square plus VC square. Okay, now what is VR? VR, you know, it is the voltage drop across the resistor, and VC is going to be the voltage drop across the capacitance. So now substituting all these terms and removing the I value outside. Okay, so I square into, you will have R square plus XC square. Okay, I'm just substituting the value of, you just listen. I will show you one more slide which will have the derivations very clearly. Okay, formulas is enough mark. Derivation, if at all they ask, you have to write. You should be aware of both. Okay, now see here, VR, we know VR is equal to I into R and VC is equal to I into XC. So substituting this both value and pulling out the current value, we are having square root of I square into R square plus XC square. Okay, or V by I. Okay, I'm just taking the square root of the current, so I will write it as V by I. V by I is equal to square root of R square plus XC square. Okay, square root of R square plus XC square. Okay, now what is V by I? We know what is V by I. V by I is going to be Z. Okay, so in a series RC circuit, okay, the impedance value is given by the square root of R square plus XC square. Okay, this is clear. Now next we are going to take out the phase angle. Now in the given triangle, what is cos phi? You know, cos phi is going to be the power factor. Cos phi is equal to adjacent by hypotenuse. Okay, 1 minute. Adjacent by hypotenuse. So what is cos phi? Tell me what is the value for cos phi for the given triangle. This is the triangle under consideration. Okay, or come to the impedance triangle. This is the angle phi. What is cos phi value? Cos phi is equal to R by Z. Okay, what is sin phi? Sin phi is equal to, sin phi is opposite by hypotenuse. So sin phi, very good, ma'am. Mohit, very good. Anjana Chaudhary, very good. So sin phi is equal to XC by Z. Okay, now next, what is tan phi? Tan phi is equal to, what is tan phi? XC by R. Okay, so we have got all the angles, cos phi, sin phi, and tan phi. Okay, so this is how the formula, there we will be having XL by R. Right here we will be having XC by R. This is the only difference. Okay, now next, the next one, we will be moving to the power. You know what is power? We have the real power, reactive power, and the apparent power. Okay, real power is represented by P. P is equal to VI cos phi. Okay, I will anyway repeat all this. Okay, VI cos phi. VI cos phi, what is the unit? I have told you all this there. VI, P is equal to VI cos phi. The unit for the real power is going to be watts. Very good. Next, the second power is going to be Q. Q is called as the reactive power. Reactive power is represented by, what alphabet? Q. Very good, power. Right. And what is the unit for that? What is the unit for reactive power? Yeah, the name itself tells, volt ampere reactive. Okay. And the formula for this is, formula for reactive power is equal to VI, formula I wanted. There we have P is equal to VI cos phi. Here P is equal to VI sin phi. Clear? Next, apparent power, complex of the apparent power. Complex of the apparent power is represented by, yes, very good Neha. Yes. What is the unit here? What is the unit here, ma? Volt ampere. Okay. And formula for complex power? Formula for complex power? V into I you can put, or you can put square root of P square plus Q square. Okay. These are the important formulas for RC circuit. Now, one more thing we have to define. One second. Right. Now, check out here. I have told you in a RC series, in a capacitance circuit, the current leads the voltage by 90 degrees. Now here, this is going to be a RC circuit. It is not a pure capacitance. So the 90 degree reduces to a phase angle phi. Okay. Now this is the phasor diagram. This is the waveform representation. If you see here B is equal to Vm sin omega t. Okay. The normal sinusoidal voltage V is equal to Vm sin omega t. What about I? I we have marked here with this format. Okay, in the blue it has been marked. I think it is, you're able to see it properly. I is equal to Im sin omega t plus phi. So plus phi, it is starting with a phase angle with an additional phase angle from 0 degrees. See, if you see here, we are just writing V is equal to Vm sin omega t. And here we are writing Im sin omega t plus phi. So what does it mean? Omega t plus phi. So angle of phi is added there, right? So because of this, what happens? The current is going to lead the voltage. Okay. So if you see here, this is the current waveform. The current waveform is leading. It is going ahead of the voltage. So this is the phasor representation or the waveform representation. Okay. All others you will be having the same. Okay, whatever we have derived, cos phi is equal to R by Z. That's what we have derived. P is equal to VI cos phi. Unit is watts. Q is equal to VI sin phi. Unit is volt ampere reactive. And complex or apparent power, unit is, what is the unit? Unit is going to be volt ampere. Okay. Next. I think it is clear now. We will go into a problem. Right. Just go through this problem. A capacitor having a capacitance of 10 microfarad, okay, is connected in series with a non-inductive resistor of 120 ohms across 100 volts, 50 hertz. Calculate the current, real power, and the phase difference between the current and the supply voltage. Clear? So now the capacitance is given here, connected in series with a non-inductive resistor 120 ohms. So it is going to be a RC series circuit. Okay. Now as it is going to be RC series circuit, see whatever might be the problem, please draw the circuit because drawing the circuit carries some marks. Okay, please draw the circuit whatever you had understood out of the equation. So this is going to be RC circuit. Okay. Now capacitance is given. C is equal to 10 microfarad. Micro is going to be 10 power minus 6. Okay. Next. Resistance value is given. Resistance value is 120 ohms. Clear? Now, first you have to calculate the current. Now we know the formula. I is equal to V by Z. V by Z. Okay. Now here they had asked us to calculate the current, right? Now for that voltage is given. What is voltage? Voltage is going to be 100 volts is given, right? Impedance you have to calculate. Now, what is the impedance value? What is the formula for impedance? Someone tell me the formula for impedance. This is going to be a RC circuit. So what is the impedance value? What is going to be the impedance formula? Formula only I wanted. Impedance. We have derived previously. Square root of R square plus XC square. Right? Now, how to calculate XC now? Capacitance is given. Now, don't raise and last 5 minutes I will give you for doubts. Okay, 5 to 10 minutes I'll come for you. Okay, so please wait. Now XC, how to calculate XC? Capacitance value is given. So you can calculate XC. XC is equal to 1 by 2 pi FC. Okay, 1 by 2 pi FC. Okay, now what is capacitance? Capacitance is 10 into 10 power minus 6. Frequency is given to be 50 Hz. Okay, frequency is given already 50 Hz. So 1 by 2 pi F into C. Now calculate and tell me XC value fast. XC value. One answer I got. Arul Mohit I got. Okay. What about others? See, please have a notebook, calculator and a pen in front of you while attending the electrical class. You will feel it very difficult in exam point of view if you are not working out. If you are working out, it will be very, very simple. So please work out. Only one student had given me the answer. How can I proceed then? Right now, after calculating, after calculating XC value, calculate impedance value. Impedance, you know the formula, right? Z is equal to square root of R square plus XC square. Okay, R square, R value, you know, it is going to be 120 ohms, right? Z is equal to R square plus XC square. Find out and tell me impedance value. Impedance value, you tell me fast. Only one answer. Right, answers I will tell you. Right, after calculation of impedance, they had asked to calculate real power. Now, real power, what is the formula? P is equal to VI cos phi. Okay, VI cos phi. Now, cos phi answer you know, right? Cos phi problem, what is the formula? How to calculate cos phi? Cos phi is equal to, yes, cos phi is equal to R by Z. Now resistance value is given. Z value you had already calculated. Find out cos phi and then substitute. You will get the value of the real power. Voltage is given. Voltage is going to be 100 volts. Current we had already calculated. So substitute, you can get the value for P. P is equal to VI cos phi. First you calculate, then only we can proceed. Ariyatma, I got one answer. What about others? Ariyap. See, simple formula P is equal to VI cos phi. Cos phi calculated by the ratio of resistance to impedance, R by Z. Okay, or directly you can put there and calculate, no issues. Right. After the real power, you have to calculate the phase difference between the current and the supply voltage. Phase difference, that's what we had calculated, right? Cos phi we had calculated. So that is the same. Cos phi, you can just take I is equal to cos inverse of the obtained value. Okay, I will display now the answers. Just check out your answers. X is equal to 318. Many of them have got 318. Okay. X is equal to 318. And Z is equal to square root of R square plus X square. So it is 340. 340, yeah. Next, current is 0.294. 0.294. Okay, average power is 10.38. And phi is equal to 69.3. We write it leading because as it is a RC circuit, we will write it leading. If it is going to be a RL circuit, you have to write it as lagging. You have to always write the position of current. Don't get confused. You just remember with respect to current or with respect to voltage. Don't confuse both. Then you will write it wrongly. Okay. Complete this fast so that we will move on to the next problem. And one more thing about the assignments, please wait for the announcement. Okay. No need to do your assignments which has been posted in the LMS. Okay, that is not for you. That is for the previous sections for A1, B1, C1. Okay, not for you. Okay, because it is with respect to Unit 3. Unit 3 we have not even started. So no need to write the assignments. Okay, we will be intimating you. You will be getting a separate schedule. We will be intimating you. Then only you can start writing. Okay. Calculator, of course, is allowed in the exam. Okay. Right. Now we'll proceed with the next problem. A capacitor and a resistor. Now you are going to do this. I'm not going to do this. You are going to do this. Please listen. A resistor, a capacitor and resistor are connected in series to an AC supply of 60 volts and 50 yards. Okay, the current is 2 amperes and the power dissipated in the resistor is 80 watts. So the power is given here. Calculate the impedance, resistance, capacitance and the power factor. Okay, first read the question properly and then start doing it. You are going to do it fast. Before slide you wanted me to show once again. Wait, Arun Mohit, wait. Okay, I will go to the question slide now again. Right, now proceed fast. I'll give you 5 minutes. First, write down the given data. First, draw the circuit. Check whether it is a RC circuit or a RL circuit. Draw the circuit. Then proceed doing. I've given you now all the formulas. Right, you have all the formulas in your hand. So think and apply which formula. And then work out. Yes, done. Right. This is a very simple problem only. Many of them would have got the answers. Okay. Now coming to the problems. Capacitor, resistor connected in series, supply volts is given, right? Current is given. You have to calculate the impedance. So first, apply the formula I is equal to V by Z. Okay, can we apply that? I is equal to V by Z, right? So we will put I is equal to V by Z. Impedance is required now, right? So Z is equal to V by I. Voltage is given. Voltage is equal to 60. 60 and current is 2. Okay, so 60 by 2, 2 will have, the impedance is 30. Okay, what about resistance? Impedance is 30. Impedance is 30 now. Okay, what about resistance? How to calculate resistance? See, the power is given here. The power dissipated in the resistor is given. So you can simply use P is equal to I square R. Okay, power value is given. The current value is also given. So calculate resistance value. Okay, now impedance, resistance you have calculated, right? I will tell you the answers later. Let others calculate. Simply telling the answers will not help, right? Right. Now after resistance, you have to calculate the capacitance. Now capacitance, how to calculate? You know the formula, Z is equal to square root of R square plus XC square. Okay. R square plus XC square. Okay. Now impedance is given, resistance is given. You can simply calculate the XC value. After calculation of XC value, you know XC is equal to 1 by 2 pi FC. Okay, XC is equal to 1 by 2 pi FC. So frequency is given. What is the frequency? Frequency is 50 Hz. Okay, so apply that and find out the capacitance value. Fast, find out capacitance value. Fast, I will wait. Okay, ma. Suraj, right. Next. Resistor power is 80. 80 divided by 4 it will be. Okay, so it is 20. Resistance value is 20. Now find out XC value. No need to write the assignment. Assignment is not for you. Assignment is for A1, B1 and C1 sections. Not for you. Okay. No need to write the assignments at all. Assignment, once it is, they'll be giving you a schedule for you. Take square root, ma. Take out your calculator. Calculate and tell me. After XC value, find out the capacitance value. What is the capacitance value? Tell me. Apply C is equal to 1 by 2 pi F into XC. Apply that formula and calculate. I'm getting the answers. Calculate. I wanted each and everyone to calculate. Hurry up. Yes, great. Bhavna. Calculated the next one also. See if you have calculated the capacitance, find out the power factor. Power factor directly R by Z, you can just apply and calculate. Okay, for others, you can check your answers. Answers I will display it now. You can check your answers. Right. Check your answers. Many of them have got this answer. See, assignments posted in the LMS is for, as for now, it is for A1, B1 and C1 section only, not for E1, because that is from Unit 3. Unit 3 we have not yet completed for you, right? We are only in Unit 2. Unit 2, we are in AC circuits, right? So, no need to submit the assignments as of now. Okay. Clear? XC value is 22.36. You've got 22.36, and from that you can calculate the capacitance. Capacitance value is 142 into 10 power minus 6. Okay, 142 into 10 power minus 6, you can write it as 142 microfarad also. 142 microfarad. Okay, next power factor. Power factor cos phi is equal to R by Z. Okay, resistance we had calculated, Z also we had calculated 30. So substitute 20 by 30, will get as 0.68. Clear, ma? Have you got the answers? Can we proceed? Can we proceed, ma? Have you completed? Only two of them permanently replying out of 230. What about others? What about others? Completed? Right. Okay. We'll proceed to one more problem. See, problems are equally important in this unit. Okay. Now check this problem. Now you are going to do this problem. Check out this problem. A metal filament lamp rated at 750 watts, 100 volts is connected in series with a capacitor across a 230 volts 60 hertz supply. Calculate the capacitance required and the power factor. Right? Now a metal filament lamp has been given. What lamp is what load, ma? What type of load? Lamp is going to be a lamp. Lamp is going to be a resistive load. Okay. So the resistive load is connected in series with the capacitance. So what type of circuit it is? What type of circuit it is? RC circuit. Yes, very good. Right. Now the power across the lamp has been given. Okay, it is not the power across the entire circuit. It is the power across the lamp alone. So you can use that value for calculation of the resistance alone. You can use it. You cannot take as the power drop across the entire circuit. It is the power drop of the resistance alone. Okay, now I have given all the clues. Find out the capacitance value and tell me how you have calculated. Fast. Calculate the capacitance. I'll wait for 2-3 minutes. Fast, ma. First write the given data, draw the circuit, then apply the formula. Once you're calculated, you tell me, such that I'll proceed. Hurry up. One answer I got. You see, once the class had started, please check your net connection, because always in waiting room, some 10 people are there. It is very, very difficult for us to always check the waiting room. Okay, please check your internet connection. And once you have entered the um, classroom, please don't try to move out. And please enter with your roll number and name. Then only attendance will be given. Otherwise, attendance will not be given. No, ma, we are not supposed to disable the waiting room. Ma. Waiting room should be present. Okay. If waiting room is not there, then you will be able to move out and come in any time. You will not have any control, right? Right. Have you worked out completed? Completed. Completed. Check your answers now. See, we have been given the power as 750 watts and the voltage is 100 volts. Okay, so we know the formula W is equal to I square R. Okay, power is equal to I square R, or the power is also equal to the product of voltage and current. Okay, so this is in regards with the resistor alone. So we are putting it as VR into I. Okay, or from this equating this both, I can calculate I is equal to W by VR. See, whatever method you are employing, it is right if the answers are right. You can follow any method. Okay, it is not strictly that you have to follow this method or that method. Okay, so I is equal to W by VR, or W value we know it is 750 watts. So 750 by 100 is going to be 7.5 amperes. Right? Now next, now we have to calculate the capacitance value. Right? Only the current is given, the impedance also is not given. Right? So what we will do, we will first calculate the voltage across the capacitance. So voltage across the capacitance, we know V square is equal to VR square plus VC square from the triangle, right? From the RC triangle. Remember that illustration given for RC circuit, right? So now here we know the voltage drop across the entire circuit, that is going to be 230 volts, right? 230 minus the voltage drop across the resistor is 100, it is given. So 230 square minus 100 square is equal to square root of the entire thing is 207 volts. So BC we have got it as 207 volts. Okay. Now to calculate the XC, now we are now checking only for the capacitance, right? Because we wanted to calculate the value for the capacitance. So calculate XC value. We know the voltage drop across the capacitance VC is equal to I into XC, right? Or as the current value is known, you can directly calculate XC value. XC is equal to VC by I. So that will be equal to 27.6 volts. Okay. So XC is found out. XC is found out. So you can find out the capacitance value, right? Capacitance is equal to 1 by 2 pi F XC, right? Next, the power factor. Power factor is given by R by Z. So R by Z means it will be, you have to calculate the resistance value first, right? Resistance is equal to P by I square, P or W by I square. Okay, so that will be 13.33. Resistance you can calculate in any other method also. Okay, whichever is easy for you, you can calculate that. So resistance we have got it as 13.33 ohms. So cos phi is equal to R by Z. Okay, employ that formula and find out the cos phi value. Cos phi value is going to be 13.33 divided by 30.7. Okay, what is the answer you are getting? Tell me cos phi value. Cos phi value, tell me. Capacitance and C value and cos phi value, you tell me. 0.43, okay. Right. 0.43 is correct. Capacitance value. Capacitance value, XC value. Not XC, C value. XC value I had told you. C value, you tell me. C value I wanted. Capacitance value. You calculate capacitance. Tell me capacitance value. 9.6 into 10 power minus 5. Arud Mohit. What about others? So 10 power minus 5, you make it as 10 power minus 6 and call it as microfarad. Yeah. Very good. Okay. Right. Everyone has got the answers? Everyone has got the answers? Shall we move on? Right. One more last problem with RC. Next, we will be moving on to RLC. Okay. Right. Now check out this problem and work out fast. The resistor R in series with capacitance C is connected to a 50 Hz 240 volt supply. Okay, frequency and voltage is given. Find the value of C so that R absorbs 300 watts at 100 volts. So what is this 300 watts and 100 volts? The power drop across the resistor and the voltage at the resistor, voltage across the resistor is given. Now with this data, you have to find out first the value of C. Okay, C and R you can find out first. Please find out that. Then I will tell you how to find out the maximum charge and maximum stored energy in the capacitor. The second part you leave it. First part you find it out. Hurry up, hurry up. Getting the answers. Manasa, very good. What about others? Others, please hurry up. It's connected to a 240 volts. So this supply is 240. Okay, and the power across the resistor is 300. And voltage drop is 100. Okay, voltage drop only for resistor has been given out. You can find out like the previous problem. Previous problem, we found out the voltage drop across the capacitance and then we found out all others. You can proceed like that also. Or you can follow any method. You can find out first resistance value and then find out all others also. That is also correct. Find out first. Meanwhile, I will check out all other doubts and come. Who is having doubts now? What doubt are you having? Raise your hands or put in your chat box so that I'll unmute you. What is your doubt now? Any doubts is there? Tell this. Somewhere raising hands in between. What is your doubt now? Please post it here. RC, we are completing with this problem. RL, RC, any doubt you can ask. Those who are not having any doubt, please proceed and find out the value for capacitance. Any doubts till now? Right. Right now, very good. Now see here, the voltage, the entire voltage is given to be 240 and frequency is 50. Okay. Now first to find out the capacitance value, we are using this formula V square is equal to VR square plus VC square. So with that I can say VC is equal to square root of V square minus VR square. Okay. So with that we are finding out the voltage across the capacitance. Okay, so voltage across capacitance is 218.2 volts, right? Now with this, after finding out the current value you can just equate it. Okay, we had got that as 300 watts. It has been given 300 watts. Power across the resistor is 300 watts. So with this we can find out the current, right? I is equal to P by V. Okay, power is given to be 300, voltage is given to be 100. So with this, we can find out the current value, right? So now current is known, VC is known. You can find out the XC value, right? After finding out the XC value, find out C value. C value is going to be 1 by 2 pi F into XC. Okay, so C value 43.77 into 10 power minus 6 farad. Many of them had got it. I think many of them had got it. Yes or no? Those who have messaged me had got it. What about others? C is 43.7 micro. Micro is 10 power minus 6. Okay. Now next, they have asked us to calculate the maximum charge. Okay. Maximum charge, this is the formula. Maximum charge C into V max. C into maximum of VC. What is VC? VC is the voltage plus the capacitance. Now we are calculating everything for capacitance only. Okay, charge is stored only in the capacitance, right? Now how to calculate maximum of VC? Maximum VC using this formula, √2 into RMS value of VC. Okay, RMS value we already know it, right? So with that you can calculate the maximum of VC. So if I calculate maximum of VC, I will get it as 0.0135 coulomb. Okay, 0.0135 coulomb. Are you getting it? See, this is how we are calculated. Yes, right. Okay. Next, maximum energy stored. Maximum energy stored, we are using the formula half into maximum. See the formula I displayed you here. Please note down the formula because it will be useful for your others. See, half into C into maximum of VC square. That is the formula. See the formula I put it down. See, half into C into maximum of VC square. Maximum VC square we already calculated, right? So half into C into C value is 43.7 microfarad, right? Into 308.6 the whole square. Okay, tell me the maximum energy stored. I've given you all the answers. Now tell me the maximum energy stored in the capacitor. Wait. We'll complete this. Fast. Yes. 2.08, right? The previous slide you wanted. Previous problem, last slide. Okay. Right. Any doubts you have, ma? As of now, any doubts you have? Deepa, ma'am?
Yes, ma'am.
Okay, ma'am.
Yes, ma'am. Thank you, ma'am.
Thank you.